at some point this music's going to end, there's going to be a cadence, there's going to be a full stop, a big crash, a big noise, something that lets you know that it's finishing. And Eno's work really tried to abandon that. Tried to walk away from music that was structured like that, but more towards a kind of more eternal type of music that's always on. Just like the soundscape is always on. Just like when you're waiting for an aeroplane, you might be waiting there an interminable amount of time. This sort of this wait that you don't know how long it's going to be because your plane's delayed, and so a kind of music that fits part of the experience of living more closely than this thing that we sit back and watch. And Eno's work, I suppose, he was worked in all sorts of different areas, so it's not right to say he's just an ambient composer, but he has definitely been interested in this notion of a structural material and also in algorithmic systems. So he's one of these guys who's also part of the digital soundscape philosophy. You can download an iPhone patch, I think, that gives you kind of infinite permutations from basic musical materials. Again, this sort of eternal thing. It doesn't have a structure. It's just an experience that you turn yourself onto for a certain amount of time and then walk away from. Of course, Eno's not the first guy to say this sort of thing, but he's certainly one of the first guys to reach the popular imagination for these kinds of ideas. And that's the late 70s. And there are 4 ambient albums by Eno with various collaborators that you probably enjoy putting on at a party. Here's someone else whose works. This is not digital. This is electronic, but it's not digital. What am I playing you? I'm playing you a piece of work by Christina Kubish, who's one of the founders, I suppose, one of the early practitioners in sound art. She's quite prolific as a creator of sound art and a writer on the subject. So she's a useful reference. This particular piece is especially spatial and architectural because the way it works is you have a specially modified pair of headphones, and these headphones are susceptible to magnetic radiation, radio waves, rather than normal radio waves. So very high frequency radio interference gets translated into sound on these headphones. So you get a pair of headphones in the gallery or wherever the exhibition is being held, and you walk around your environment listening to the sounds that TVs and projectors and computers and various other things make. And this is quite a beautiful work because, of course, these sounds are there all the time. They're just not within our range of hearing. The headphones transpose it into a range that we can hear, but it's a piece of music that you make yourself by walking around your environment. Your attention is drawn, especially to sound, to hearing. When you walk next to things like pedestrian crossings, the sound is so absolutely, awfully, horribly loud that you definitely pull away from it. And this is quite interesting because it changes the way you interact with the space around you. You become a different person in this space when the world is suddenly sonic, and you're an agent within it. You start to behave differently, and you get to hear the kind of life of these things that's going on all the time that normally you don't get a chance to experience. So I definitely try and recommend you try and get to one of their exhibitions and put some of these headphones on and draw attention to those things that are out of the range of hearing. She's done compositions with this stuff as well, so by stretching wires with the magnetic radiation going through them around the room, then there's a sort of sound space created that you can't hear. You put the headphones on and then you walk around and drop and bring yourself close to these cables. And so a new space, a meta space, an alternative space is described by these sound waves, these magnetic waves. Okay, digital soundscapes. Well, hopefully we'll get a chance to discuss this bit, because this is a problematic term for me. I find it very hard to think about digital soundscape as being anything really useful. At least I did at the beginning, preparing for this talk. The first use of the word digital soundscape in kind of creative music practice, it comes from Barry Truax in 1989, I think it is. 1986, piece called River Run that he made with a special technique called granular synthesis. What he tried to do here was create the sound of a river, but entirely through computer-based techniques, through digital techniques. So entirely synthesized sound, but the sound's kind of like a natural phenomenon, water, using this technique of granular synthesis. And you'll notice one of the things about this description, I'm not going to read it out. One of the things about this description is it spends a little bit of time talking about water and a whole load of time talking about granulation and granular synthesis. And one of the things that I get from this, and I get from a lot of my way I work with computers and lots of my colleagues, and the things that we end up doing is we get wrapped up in all of this technology. And it's certainly a feature of the digital. To some extent, you're not hearing the water or the emulated water, but what you're hearing is the technology, the processes that have gone into making this thing. And that's a key feature of the digital. It's one of the, I don't know if it's negative or not, but it's certainly a problem that you're thinking in one way, but what you're actually doing is something else, perhaps. Or what you're actually showing or revealing is something different. So have a look at Barry Truax's work. Try and have a listen to that piece if you can. What else have we got? What is digital? Are we there already? Oh, good. Well, you could get dictionary definitions of digital. Chris has already told you what digital is, or you've discussed and tried to get to the bottom of digitalism for us. I suppose in the sound world, one of the most important distinctions is digital is expressed in discrete numerical form, especially for use by computers or other electronic devices. Digital information, but discrete numerical form. This is one of the problems I've got, one of the difficulties I've got with trying to think about sound and digital in the same thing. We've experienced listening already this morning. We've listened to this thing that arguably flows, trickles, runs, changes its parameters very, very quickly, very, very flexibly. Is beyond parameterization to some extent. Bristolow's categorization system is very poor, it's really difficult. All the categorization systems I've come across that try to put sound into boxes, it always resists it. Whereas the digital is this quantized numerical definition of something. It's an absolute thing. In sound, if I had a pen and could draw, I can't draw on that, can I?
No, forget.
So, okay, imagine there's a graph in front of you, and there's a sine curve on it, like that, okay? You've probably all seen these sorts of things before, sine curve, and then the digital description of that sine curve is a bunch of lines that give a numerical value for each point on that curve. That means that there's a bit of space in between that is not defined. also means that the numbers that you use to describe those lines pointing up like that, how high those lines go, or how precisely they're defined in relation to one another, something called the bit depth or the word length, is another really important thing. If you're working at 16-bit, which is the CD quality, with 44,000 sort of readings per second, and 16 bits of information, 16, so that's I think 64,000 words, 64,000 different possible spellings. It's just not enough. It's just not enough at all to really describe the sound of the world. Now, it's still high fidelity. It can sound absolutely incredible, but it's nothing like what's really going on. And having heard some of the really best converters you can buy in the world, I can tell you that sound coming out of these computers and sounds coming out of these CD players is not a description of what's really there either. So that's interesting. We're making a leap with all the stuff that we have represented in digital form. We're making a leap back into the world. Let me just quickly describe the digital system. Discrete description, here's a benefit, infinitely reproducible without loss. In the analog domain with sound, you'd record it, put it onto tape, then to get it again you have to play it through the tape would degrade a little bit, you play a record would be scratched literally, physically by the needle on it, that would wear it down a little bit and it would change every time you play it back. On a computer, it doesn't change. If it changes, the system isn't working, it's broken and something needs to be fixed. It's data-based, it's data-centric, and its representation is central to any digital system. It's very easy to reconfigure to some extent. You can swap. You might describe your numbers like that. You multiply it by -1, and the numbers are described like that. Really easy to change things by simple modes. It's lightweight. I've got an enormous amount of sound sitting on this computer. I carry it around anywhere I want to go. It's cheap by comparison with analog stuff. And it's predictable. I don't know what I mean by that. Maybe you can tell me later. Very quickly, I want to tell you what happens in a sound system, in a sound-based digital system. I know you may go away and think about sound again after this session, but if you do want to use sound creatively, or if you think it might be important to you, this will be helpful. Sound input starts with a microphone. That's an electronic device. It's a transducer. It's a transducer. It converts the movement of air molecules, which is what sound is conveyed on, into